How about I start with like a very brief intro so that everybody who already joined know what we are going to talk about today. So I'm sure that you are aware that as manufacturing is shifting towards smarter solutions, that more factories are adopting real-time data processing technologies to boost production efficiency, detect anomalies sooner, and improve supply chain integration. So a lot of these challenges can be addressed, and pairing up Coreflux and RisingWave become a strong choice for manufacturing businessing seeking to address some of these challenges. So with us today, Hugo Vaz of Coreflux and Emily Rhee of RisingWave, who will each showcase how Coreflux and RisingWave can work together for real-time monitoring in case of a beverage factory. So we'll start with Hugo and then Emily will continue. So Hugo, the floor is yours.
Yeah, thank you. Thank you for, first of all, for inviting us. I think, like you said, we will show during this webinar how both technologies are capable of working together. In my background here, where the place where I am actually is the lab where we develop the first integration that we actually document. I think I will show that, but I think we can put even the link of the blog post that we made together about how to integrate, how to do this integration. Works as a step-by-step, and it shows how easy it is. So Coreflux is an MQTT broker, first of all, that started as a gateway to bridge OT to IT. What is OT? It's kind of the devices that I have in my lab here. So we have PLCs from several brands. We have those PLCs are able to put machines that you find on the manufacturing floor to work those machines, to make them move, to make every living thing, every non-living thing, let's say, that we have. So, and they create a lot of data. And Coreflux is able to get that data. But from that point on, it needs to be analyzed, and we actually work as a pipeline, and we deliver that data across every different system. And in the case of RisingWave, we kind of see a way to really make a real-time analysis in the front, let's say, if you consider the devices on the back. So what we are doing here is we are showing, and I can maybe share my screen if possible. So to start a little bit. So we created this blog post that I will go through it. So what we can have here is this Siemens and Omron PLCs that are simulating a manufacturing line. So they are creating data, which in this case, it's making a bottling machine. So a machine that feeds water into a bottle. So it has a kind of you need to imagine the machine, of course, but it has a way to analysis if there is any not okay situation, and if there is a bottle that was produced. And what we have is what we call connectors on our side, which connect to a certain device. In this case, I'm using the one from Siemens. And then this goes into my laptop, which is let's say, the edge device that's inside the factory that's sending data to the cloud. And I will show what this cloud is that reaches RisingWave. And in the end, it goes into a Grafana dashboard. So this is the flow that we want to show. So in a very straightforward way, what we have here is our broker running locally and running with two connectors. One that's acting as a connector to the device that I have in the back, that's really running the data internally, and it's putting that data into my broker. And I have another one which acts as a bridge to another broker that was set up for Emily. And what it happens is I'm using this local, I can connect to it. This is an MQTT Explorer. So if everyone is familiar with MQTT, usually is the protocol that nowadays it's becoming the election protocol for event-driven data in the manufacturing floor. So what we have here is the device, it's propagating this data, which is a JSON content that it's being generated inside the device, and we are copying that data as a message to this specific topic using the connector. And this message goes to the broker that was set up by Emily through the bridge. So within Coreflux, you can see we have two assets, one that's running the MQTT bridge, and one it's running the S7 to MQTT. So it's kind of a translator from Siemens S7 protocol into MQTT. And this specific data that's coming through here goes to the broker where Emily is connected. So this is a broker from within our cloud. So I'm based in Porto, and this specific broker is running on San Francisco, where I think it's more, it's a very more specific region, more less latency for RisingWave service. So what we are doing here, we are pushing from Porto with the bridge to San Francisco to a specific broker. So it's an MQTT connection. So first of all, we have the device, which is a Siemens PLC. There is a connector that was created to put that data into an MQTT broker that's running on this computer. And this computer has a bridge to this server that was set up prior in our website. So you can go to mqttcoreflux.org and you can set up a free broker for 7 days in order, and you can select a specific region to set it up. So we have San Francisco, Frankfurt, but anyhow, this is the way we are handling this MQTT broker. So this specific JSON has all the information that Emily requires. So there is a machine ID. There are a couple of signals to say if the machine has the filling has started, if the filling is okay. And every time a bottle is made, we get an okay message saying we now have 250 bottles and 15 bottles that are not okay. And we can see on each bottle the type of not okay status that the bottle had. So bad cap, did not fill to minimal value. So the device is simulating this data, and also it's placing a timestamp in order to have a specific timestamp for every message that we send. So for very brief, this is running, so I cannot stop, but we have a configuration here where I can set up all the tags that we have. I should stop it, but I will stop it and explain afterwards, show all the tags afterwards. Let Emily now maybe show what she will do with this JSON file, that she's able to put it back, because I can show afterwards the configuration of the tags, what we have in terms of explaining the signals. So maybe I will pass to Emily now.
Yes, thank you, Hugo. Yeah, so I will be taking over the RisingWave portion and talking about how RisingWave is going to ingest all this data from Coreflux, process it, and then we'll create some materialized views that does analysis on this data so that you can sort of keep track of the efficiency of your machines, if there are any anomalies, and then you can be alerted to if something is past a specific threshold for you. So I'll go ahead and share my screen. So we're going to be using RisingWave Cloud today. There is a self-hosted version of RisingWave if you do want to set that up, but RisingWave Cloud is a lot easier to work with. You can sign up for a free trial account at risingwave.cloud. Already have an account set up, and when you first sign up, you're just going to be prompted to create a new project. And we can just rename this project to be our Coreflux integration project. Can select a service provider, your region, and your compute size. Since this is a trial version, the default is 2 RWUs. 1 RWU is approximately 1 CPU and 4 gigabytes of RAM. Yeah, and then we can go ahead and just create this project. Upon initial creation, it will take a little bit to set everything up. So I'll just briefly talk about the benefits of RisingWave and exactly what it is. So RisingWave is a SQL platform for event streaming workloads. You can ingest data from a variety of messaging systems. Today we'll be focused on Coreflux and its MQTT Broker. It's an open source project and it's already been deployed in various industries. And like I said, you can deploy it via our open source project locally or RisingWave Cloud here. RisingWave Cloud or RisingWave, it's Postgres compatible, so everything is done in SQL. So everything I'll be doing today in our workspace is just going to be SQL queries, from the ingestion of the data to the analysis and a little extra something we have planned at the end. And then another main feature of RisingWave is the availability of materialized views. Materialized views store the results of a view expression, and you can join data streams from like different sources, transform them, whatever else you need to do. And the results are always updated because the results are computed whenever new data arrives. And this saves significantly on computing resources because you don't have to go back to all your backlog of data and recompute everything. And we'll have like a full set of stream processing features like time windows, watermarks, temporal filters if you need them. If everything's like very time sensitive, you can keep everything in order if you need. And for like more complex transformations, we also have UDFs, so you can define your own functions. Yeah, so thankfully the project has created while I did my spiel about RisingWave, so we can go ahead and head to the workspace. And here, everything is, again, going to be done in SQL. You'll run your SQL queries here, and then you can keep track of like your sources, tables, materialized views, and whatnot. So let's go ahead and get started by connecting to that Coreflux broker that Hugo described. In this case, we'll be using a create table command. So you can either use create table or create source. They'll do almost the same things. They'll let you connect to this broker and start reading data from it. The difference is that this table will persist the data in RisingWave, so you can query directly from a table in this case with an MQTT broker or like this MQTT connector. If we use a source, data won't be ingested until you create a materialized view. So it creates that connection, but it doesn't persist the data in RisingWave and it doesn't start ingesting it. Yeah, so we'll name the table machine metrics, and this is the data schema. So it'll tell us the machine that the sensor is reading from, what position the bottle is in, and then like what the sensors are reading, if the bottle is there, if the bottle was scrapped, if the machine stopped, stuff like that, and the production counters, as Hugo mentioned earlier. So the data schema here, and these are your connection parameters. So where you'll specify what type of broker it is, the broker address, the topic, and all of your login credentials, and then the how many times your message will be read into RisingWave. So at least once, at most once, exactly once, stuff like that. And then at the end is just what format your data is in. So we can go ahead and create this table. And in the history tab, you'll see that it was successfully connected. And just to double check that data is being ingested, we can select everything from machine metrics and just limit it to 5 because we don't want to read in everything. All from machine metrics. And we'll see that some of this data pops up. We only have one machine connected today, so everything will be machine ID 1, and then everything else will have all of this extra data telling us if the machine is stopped, the cap situation, and the production parameters, as well as the scrap type. Yep. So once we have this data read into RisingWave, we'll go ahead and create some materialized views. And that's simply done using the create materialized view command. You'll name it, and then you'll say as and whatever select query you want. So in this case, we're going to be selecting from this table, machine metrics, using the tumble function, which maps everything into a specific time window. So in this case, we'll just be using 1 minute since we won't be here for that long. If we do 15 minutes, we won't have that much data to look at. And then in this case, we'll just be looking at the efficiency of the machine in the specific time window. And we'll be calculating it as the number of OKs out of the total number of OKs and not OKs. And we'll be grouping by the window and the machine ID, just so that we can get all of the data that we need. And it was successfully created. You'll see on the side here, you'll be able to look at the drop-down menu and what columns are available. And then we can just select from the production. Sorry, it was named 15 minutes, but it is 1 minute. And then we can order by the efficiency percentage, descending, and limit it to 5 entries. And then we'll see what time the machine was most efficient and the efficiency percentage at that time. That's one way you can, or like one of the types of analysis that you can do. We'll go through a couple more just for some more examples. We can create another materialized view that counts the number of downtime in each minute. So similar to before, we'll be using a tumble. We'll be using the tumble function again to map everything again into 1 minute intervals, and then just counting the total number of downtimes and the total number of events in each minute. And again, grouping by the time window and the machine ID. And that was successfully created, and we can just query from it again, just to see what the data looks like and if your SQL query is, if it matches, if the results match what you're expecting. And again, you can see the total number of stops and the total number of downtimes. And something else that RisingWave can do is you can create materialized views on top of materialized views. So say in the case of the production efficiency, if we want to check for instances where the machine has like a lot of not okays, we can create a materialized view on top that filters specifically for instances where your not okays is but above a certain point. So we can just name this anomaly for simplicity, and it'll be creating a materialized view again, but in this case, you can just query from the materialized view you created earlier. And then we can filter for instances where not okay is, say, like above 400. And that successfully creates a materialized view. And then we can select everything from anomaly, and we'll see that if you remember earlier, we had like that 432 and the 408, and they'll be filtered through this materialized view and show up in the results here. And something handy is that with this drop-down menu on the side, you'll also be able to check the dependencies. So if this is dependent on the previous materialized view and which table or source this materialized view is based off of. And then a handy monitoring tool we have is on the side. We can look at our sources and see, you know, the schema registry, the throughput, if we have any errors. If your throughput is a lot higher, this will obviously be not at 0, but currently my throughput here is at 0.27 rows per second, so it just rounds down here on the side. And we can also just look at the materialized views we have, and it'll show you the backend process of how it was calculated. Yeah, so that's the simple, quick run through of RisingWave, and then I'll hand it back to Hugo to talk about how we can deliver messages from RisingWave to initiate an event on the MQTT side.
Okay, thank you. So one of the things that actually is quite important and I think it creates a lot of benefit, is what we are talking about here is using RisingWave to do the analytics and to provide that analytics on real time, of course. But if we depend on someone to check, if we have a human in the middle, let's say, checking any dashboard or doing a query, or even having a manufacturing execution system that receives this data or something, kind of loses the real value that we are able to create. So the thing that makes that I think it's more important, it's to really automate this process. So if basically if we have this running automatically, having the broker and the RisingWave, and this kind of notification that Emily was showing kind of decides to send a data directly to the broker, and that data is routed into a specific handling of the machine side, we could stop the machine. Imagine if the efficiency was bad, if we had a very high scrap, we call scrap because it's parts that are produced that are not okay. If we are producing parts that are not okay, then it means the machine is it's not being effective. The whole process is not effective. So it will be better to the manufacturing floor to really decide automatically. And I think this this concept of having this analytic running and providing a feedback in the end, it will be great. So what I usually I can now share screen. What we have on the broker is that we receive a status message of the stop coming from a certain event from RisingWave. And what we are able to do, maybe if actually it's here, what we are able to do, and this was something that actually is happening, every time we get that status, under Coreflux, we can put what we call a model, which we receive. This model is like an interpretation of the JSON. So we are able to pick this model, which is a topic, and which is this one. And every time we get this event with a specific information, we kind of break it into topics, subtopics. So we have this false. And with this false or true, we are able to use the asset, the connector, to write down the information on the PLC. So what we are able to do here is to really pick the JSON, break it into data, so it's an information and it becomes data again. Because the first thing that we were doing was we were picking up data, which were signals true and false, transforming into information, sending to RisingWave, and then RisingWave is sending back a certain information, and we are breaking it into data. And this specific data we can connect to a signal. And actually, that signal can be connected here on the S7 device, which is a PLC. So this is where we define each one of the variables. The variable that's actually collecting the data, it's a string of 250 chars. So that big one that we are getting, it's coming directly from this, to this topic. But the one that we have for the specific lamp, let me start it again, is this one, true, false, which is actually this lamp that I have here on my back. So it's the one blinking. And I could pick up that information, but since it is an output and turn the lamp red, but an output on the PLC runs on certain safety issues. Because if I try now to write an output, it means that RisingWave was able to control an output of the specific PLC. We could not do that because it could be a motor, it could be a hydraulic piston or a robot to get the order to move, and that was unsafe. So usually we have to build a logic inside the PLC, but I don't have that logic. But what we could create here, it's something that really stops the machine, but that behavior inside the machine needs to be programmed, because the PLC continues, the device itself continues to have its own handling that it needs to really create. But I think this way we are really bringing what is called Industry 4.0, because we are doing the analytic where what is best, which is the cloud. We could go deeper into, okay, should we divide this into a unified namespace with all the machines? But that was not the general idea. Here we were talking only about integrating two technologies. And the idea here is that we can read data from the device, aggregate it with Coreflux, send it back to RisingWave, and by a bridge that is using SSL, because one of the things that was not mentioned is that the configuration of the bridge itself, it's using TLS. So my device here is acting as a firewall. So it's like that device is completely block of the cloud. It's not connected to the cloud. It's connected to a local network that handles the S7 connection, And there is a separation of concerns for the network that is using the cloud connectivity, which in the end it's the web. So the thing in here is that we were able to get this data, send it to a central broker from this device. It was analyzed, and it was created a new information that is able to be handled by the device itself. So every time we get a different status coming from RisingWave, we get a variable that the PLC is able to handle, because this kind of devices, they are only able to handle, okay, strings with a couple of data, but they are quite useful when you have true, false, or numbers. So this is also something that I think we are able to, it's not only in one direction, we are able to have it on both directions, and this is actually something that it's great that we are able to do this in real time in the end. So maybe I will stop. So this is what at least I wanted to showcase, what we are able to get if and I think that it was quite easy to deploy. It was straightforward, and I think it's great to see actually a way to both technology and being on one of the technology. I think it's awesome that we're able to connect, and that's the idea behind our broker. It's to connect to and be a pipeline. So I think we are able to at least provide that value, and it was quite good, and I really enjoyed to do the demo.
Yeah, I think Hugo summarized everything very nicely in terms of the synergy of both of our technologies. And just to make everything a little bit more concrete in terms of sending data from RisingWave back to an MQTT broker, I'll just quickly share my screen again for this last part, that we can create a sink that connects to that topic that Hugo was talking about. Again, the connector parameters is pretty similar to creating a source. In the case of a Coreflux, or in the case of an MQTT sync, we only support append-only types right now. So you can only, they'll only read everything as an additional update rather than as like an they'll read everything as an insert operation rather than like an update or a delete. And in this case, we can select, we can send the data from machine status, which in this case, like Hugo said, it's easier if you work with just a true or false value. So earlier, you'll see that it was just a false value, and then we can send a true statement to that MQTT broker, and Hugo should see that on his side, the broker is, it'll have a true value now.
Yeah, it's here.
Mm-hmm.
Yeah, this is my computer, so the model is already in place. So the model, it's very straightforward. It's this. So we have a model, which is in the end adjacent. On the topic, actually it was local. Let me fix this. So I was doing documentation. So this was what I was able to order. It's we simply just send the command add model inside the broker to control this specific topic, and this happens. It kind of creates. If you're able to send a false, are you able to?
Yeah, I'll go ahead and send a false.
Yeah, it's there. Yeah, so this I could connect this to stop the machine, to stop the simulation, and this way we were able to stop the bottling process. But since it's an output, I wanted to put the lamp, but an output is protected from being written by us. So it only works as an output, not as an input. So the thing is, we needed to create logic inside the PLC, but that was not the focus. My focus is only under Coreflux, but the idea is that from this point on, the integrator that's using Coreflux is able to connect this data and really change the PLC, change the device in order to act upon this order in the end, because it becomes an information as an order, as a statement. Please stop the machine because this is not working. Yeah. So yeah, thank you. This was actually quite good to see the way we are able to connect so easily in two directions in the end. So inputs and outputs. So I don't know, Giovanna, if you have anything.
No, this was amazing. Thank you both. I really enjoyed, and I hope our participants enjoyed as well. So if anyone have any questions, feel free to post it in the Q&A tab. So we already have one question. I don't know who wants to address it. The first one is, does the integration support strict event ordering?
I don't know if this is for me or for RisingWave.
So yeah.
But I can answer on Coreflux.
Please go ahead.
Yeah, so we actually, the models that we have work as input and output. So once it starts, once we receive an event on that specific topic that's defined there, or if there are any more topics, because that was not the general idea here. The idea was to show the integration. We were able to copy. We are able to do the event ordering. So we do the event ordering inside. So it's kind of a stack that runs those events and takes snapshots of the topics that were being used in order to create also this streaming process. So we are not bringing noise to the other systems, and we follow the correct timing of the events that were triggered. So, and I think also the same applies to RisingWave if the same thing happens. So, but for us, it does.
Yeah, I can't speak exactly in terms of the implementation of this integration in RisingWave in terms of like what's going on under the hood. I think that determines a lot of how the data is ingested exactly into RisingWave. But I can say that if you do need everything to be in order, you can use additional SQL queries when you're transforming your data to ensure that everything is in order. But if Coreflux ensures that all the data are like ordered properly, then the ingestion should also follow that.
Thanks both Hugo and Emily. We have two more questions. Another one from Andreas. Does Coreflux handle data persistence and retransmission when a broker connection is not available? What are you using under the hood?
Under the hood. So, okay, if it's related to MQTT, so we created our own MQTT broker, our own DSL, let's say, with all the rules in order to create with rules, with models, and also with actions. So we have those three ways to handle data, let's say. One of the things in terms of a broker, you have the retain on the standard. So you are able to keep your data as a retain, but this is not a persistency. The idea for Coreflux is to become a pipeline, but from an MQTT perspective, not as something like Kafka, I think, or like RisingWave or other kind of technologies here. So if a broker connection is down somehow, and there isn't an MQTT broker, the connectors itself, some of them have data persistency. So it depends on the protocol that we are connecting. If we are using SQL, if we are using a certain PLC. So it's kind of an answer like in some parts we have that, the connectors, in other parts it's not part of the standard. The standard is very specific. It's a pipeline that only pushes from one point to another in a very short summary. And we keep the retain flag available and also the quality of service, but as a standard we follow the standard from MQTT. So we don't create this stack of data persistency and that's off the standard, let's say, inside the broker. We leave that to databases or to Redis or any other tool.
Thanks, Hugo. I believe the next one is for you, Emily. How can external UDFs in RisingWave be leveraged to enrich IoT data streams from Coreflux?
Yeah, so external UDFs in RisingWave, they can be defined in either Python or Java, and they allow you to employ those external libraries that come with Python and Java. So if you need to perform more complex transformations in terms of how your data is, either it's structured or just in terms of analyses, you can leverage those external libraries. And then you can load that external function into RisingWave because that'll be defined probably locally, or if you have like a separate server set up, like you're a Python or a Java project, you can load that to a server and then RisingWave will read that function from that server, load it into RisingWave, and you can apply it to your data as needed.
Thanks, Emily. And the next one from Andrew, maybe like both of you can address it. Any measure to tackle back pressure between Coreflux and RisingWave?
So I'm kind of the problem here because we are the ones probably enabling this data through output that kind of can potentially create any back pressure on the RisingWave. So I think that latency might be an issue. So I will say that also the way that we defined our cluster architecture was really a demo. So I'm in Porto, but everything is in San Francisco. So we kind of used actually the MQTT events to which we are able to, since we have our protocol, it's more limited. There is no computation in the middle. So it's pure network work. It was actually better in the demo to have everything near RisingWave. So it kind of helps us adjust any potential back pressure that we might have due to the decrease of latency that we created between Coreflux and RisingWave. So we use Coreflux as a way to mitigate this latency because we are using the MQTT protocol, which is very short, let's say, in terms of necessity of communication. But I think that's the only thing I'm actually helping out. The other part that we actually were able to do, one of the tests that we did before, we were able to test more than one device. Actually, we tested all 5 devices during one of the tests, and that actually it's something that for me takes more time, but to prepare. But since I have to connect all 5 devices, but it kind of I didn't see any back pressure, so we didn't see the limit, but Coreflux is the one creating the the potential problem, because we are able to push a lot of data, but it needs to be there needs to be computation on the other side. But I will leave that to Emily to maybe to answer, because it's not I'm the one generating the issue. Yeah.
Yeah, on RisingWave side, we do have like a few tools that help you monitor the performance of all of your queries. So we'll have like those diagrams to help you identify exactly where that back pressure is rooted in, whether it's from like a create materialized view query, or if it's like directly from the source. And then based off of that, you can try to optimize your queries either by creating subqueries or multiple subqueries, or we also have an additional tool to allow you to control the rate limit of a new materialized views backfilling process. So there are a few tools to help you to identify where the issue is rooted in, and a few different ways to kind of lighten that load. But at the end of the day, if the data coming in is too much, I think the easiest solution is just to increase your compute resources.
Thanks, Emily. So the next question from Andres is for you, but in the meantime, Hugo, you can take a look at the chat. You have a comment from Andres in response to your response. And for Emily, the question is, does RisingWave support native windowing on timestamps extracted from the data instead of just processing time? Would that require a separate materialized view and query?
Yeah, I think if I'm not mistaken, RisingWave does also read in the metadata from the actual core data. So instead of on top of just the timestamp included with the actual data schema, there is also the other timestamp associated with when the data was ingested. I will have to double check on exactly what the column names are, but I do think it is included with MQTT, unless I'm getting it confused with Kafka, but that was a different issue. So I think at the end of the day, there may be an additional metadata column that you can ingest into RisingWave, but I will have to double check if it is for MQTT or for a different connector.
Yeah, Andres, we'll get back to you on this one. So these are all the questions, unless someone have one more.
Maybe I can add something on the comment from Andreas. From OT sides to view that specific information, we are able also to build that. But for that, we need to go through every tool that we have inside Coreflux. But we have a lot of tools that you are able to use, the language itself that we have internally, all the assets that are able to connect even to local databases where you can insert data and query the data. So they are like solutions in order for you to be able to do the queue that you want to do if you require that queue. But that depends on the developer, how he wants to create this architecture, because we are not only focusing to manufacturing. So the same with RisingWave, we kind of are able to work on every type of solution. So in this place, I'm in the lab for the manufacturing devices. But just to answer the statement from Andreas, to add this to not create any confusion.
Thanks, Hugo. Thanks both like Hugo and Emily for your presentation, and thanks everyone for great questions and great discussions. If that is everything, we are wrapping this up, and we'll seeing you next week. Next week on Tuesday, roadmap reveal for the next year. So be there.
Okay.
Okay.
Thank you. Thank you.
Thanks,
Bye.
everyone.